Good morning or good afternoon, everybody. I hope you're all doing well. Welcome to today's webinar, The Waste Hierarchy as a Framework for Change, Innovation in Lubricant End-of-Life Practices, brought to you by the ATL and UEIL Joint Sustainability Committee. The webinar relates to the recently published document, the End-of-Life Sustainable Best Practices Guidelines. If you haven't yet read this, then I would encourage you to scan the QR code that you can see on the screen so that you can peruse, read along and refer to it. It's something that we are incredibly proud of. So my name's Gemma Stevenson and I'll be moderating the webinar today, but I'm delighted to be joined by a panel of fantastic industry colleagues. So you can see them on the screen. We've got Joris, Paul, Glicaria, Mark and Andreas. Before we start presenting the content, I'd quickly just like to cover some housekeeping points. So firstly, the webinar is being hosted and recorded by the UEIL Secretariat. Should you not wish to be recorded, then please do opt out from participating. So for example, in the Q&A, if you choose to submit a question, your name will be visible to others. Your microphone and camera functionality has been switched off automatically though. The webinar duration will be 1 hour, so we're aiming for around 40 minutes of presentation followed by 20 minutes of Q&A at the end. And in the Q&A session, we really encourage you to ask your questions. You can use the Q&A button at the top of your screen. I think it's next to the chat in Teams. And one cool thing about this is that you can like questions that have been posted. So at the end, I can use these to prioritize the most liked questions, the most interesting ones, and I'll put these to the presenters at the end. Lastly, if you do experience any technical issues, then please make these known to the Secretariat who's monitoring the chat box. So for the webinar structure, our expert panel will perform a deep dive into the waste hierarchy, which is the key concept that really underpins the end-of-life best practices document. What we're going to do, though, is start at the bottom of the triangle and make our way through the different aspects, the different levels, moving from the least preferred to the most preferred approaches to lubricants at the end of their life. Each area that we cover today is explained in greater detail within the end-of-life document. So today just aims to give a flavour of what's covered, and that is really delving into chapter 3 of that document. So to kick off, Joris will cover disposal, looking at environmental and health risks, and then how to dispose responsibly. Paul will then look at used lubricant recovery and secondary fuel use. Glicaria will cover the recycling portion, delving into topics such as re-refining and the benefits of re-refined base oils. Mark will explore how we can prepare for reuse of lubricants, and we'll talk about reconditioning methods and benefits. And last, by no means least, we'll come to Andreas to think about prevention, the most preferred stage of the waste hierarchy. And Andreas is going to cover things such as condition monitoring and service life extension. But firstly, I'd just like to briefly explain the role of ATL and UEIL and the Joint Sustainability Committee and look at how and why this document was developed. So you may or may not know that the ATL and UEIL Joint Sustainability Committee was officially formed in June 2024, merging the two individual committees of ATL and UEIL, the two sustainability committees. And this group was created to address shared environmental and legislative challenges, and its mission is really to promote responsible sustainability strategies to members, advocate for industry best practices, and to provide practical tools and guidance to members and stakeholders across the lubricants, greases, and specialty products value chain. To look at key focus areas effectively, the committee is split into 4 working groups that you can see on the screen there. We've got the carbon footprint working group, looking at exactly that, does what it says on the tin, a circular materials working group, and a communications working group that disseminates the outputs effectively to the wider industry. It's the task of the downstream working group, though, that focuses on lubricant performance, benefits, and end-of-life sustainability. And we've got more on this on the next slide. So as we transition from the committee's formation to its practical impact, it's the downstream user group that really comes into the fore here. And this is where sustainability meets real-world application. So they focus on how lubricants perform during the use. That can be reducing friction, improving energy efficiency, but also what happens after when products reach the end of their useful life. So the work in this group is crucial in shaping how we think about sustainability beyond just a product. It's about the full life cycle, how we use, recover, and regenerate these materials to minimize environmental impact. And that really brings us to the heart of today's webinar. So why we're presenting to you today. And I really like this quote on the screen because true sustainability comes when we see the full journey. Every stage matters and every impact counts. So now we're going to explore how end-of-life practices are evolving to support a more circular and responsible future for lubricants. And it gives me great pleasure to hand over to Joris to cover the first step in the waste hierarchy, which is disposal.
Thank you very much, Gemma, and thank you for the kind introduction as well. I would like to dive right in. So can you move it to the next slide? So let's start at the bottom of the waste hierarchy, which is disposal. I'd like to start with an example of how things are not to be done. And that's from if you look at the picture on the right of the slide, it's actually from Popular Science in 1963. And at that time, oil was just disposed by digging a hole in the ground and pouring it into the ground. And that's actually what we want to prevent. And why we want to prevent this is that, I would like to go to waste oil. When waste oil forms, the lubricant loses the performance or becomes contaminated, and it contains hazardous substances like heavy metals, polycyclic aromatic hydrocarbons or acids, and not limited to these. But it's important that we don't really have these hazardous substances in nature, in soil, in water, because it can contaminate, but also human health in a way. Under the EU waste law, disposal is actually the least preferred option and used only when recovery or reuse are not feasible. So our goal as an industry is basically to minimize the need for disposal. It's where waste should end and not begin. So I'd like to move to the next slide, please. So improper disposal has serious consequences, and two of these consequences are mentioned here in the slide. You have environmental risks, but also human health risks. If we start with the environmental risks, it's good to start with an example which shows the impact of things. Basically, 1 liter of waste oil can contaminate 1 million liters of water. So it pollutes soil and aquatic ecosystems, but also can enter into the food chain. So if you think about uncontrolled incineration, this will emit greenhouse gases, but also toxins. And at the end, it also increases the product's cradle-to-grave carbon footprint, which is, of course, bad for global warming. Then if you look at the human health risks, waste oil contains carcinogenic and toxic substances like polycyclic aromatic hydrocarbons, but also heavy metals. Exposure may cause skin irritation, respiratory issues, but also organ damage. But groundwater contamination also threatens drinking water. So disposal must be controlled and limited to hazardous waste oils only. And this is really, it clearly shows why safe disposal is essential and why we must prioritize higher steps in the waste hierarchy. And with that, I would like to move to the next slide if we speak about disposal and if other steps in the waste hierarchy are not possible, then there are ways to dispose responsibly. And in this slide here, you see 3 elements, starting with plan and prevent, but also regulatory advice and also how to minimize the impact of waste. And if we start with plan and prevent, you can do that by, for example, implementing a used oil management plan, but also by storing and labeling used oils or used lubricants properly. A lot of the oils that in the end become waste are also because oils reach the end of the shelf life. And so by improving that and planning and preventing, you can reduce the disposal part. Then on the regulatory sides, use licensed facilities, maintain transport and disposal records, but also comply with EPR and local legislation. On EPR, so extended producer responsibility, there will be more information given later also in the presentation. Then the last part is to minimize the impact, for example, by having localized treatment to reduce emissions, partnering with waste oil contractors, but also thinking about the fact that specific biodegradable lubricants like ester-based lubricants, they can require specific end-of-life handling. For example, if you'd mix mineral virgin oils with ester-based lubricants, this can reduce the effectiveness of re-refining efforts, and it's good to take that into account. But also more on that later. And I would like to end this part of the disposal with a quote, or actually an adapted quote from the EU Waste Framework Directive, which captures quite nicely that disposal is actually the last option we should target. And the quote says that disposal, landfill or incineration without energy recovery is actually the least preferred option in the EU waste hierarchy. It should be used only when all recovering and recycling routes are exhausted. And with that, I would like to move to the recovery part and hand over the word to Paul, who will lead us into that section.
Thank you, Joris. Next slide, please. Yeah, so now we're moving up the waste hierarchy triangle to recovery. And where regeneration isn't feasible, then obviously processing the waste streams as secondary fuels and recovering the energy content provides an alternative means to utilising the waste oils. If we are doing this, then obviously the recovered fuels should meet certain specifications in terms of heavy metals, halogens, sulfur concentration, to ensure that emission limits when burnt are met, obviously regionally, country-wise, in terms of legislation, etc. In terms of the how much of the waste streams are recovered and used as secondary fuels, then the EU Commission in October 2023 put a report together that estimated the total as 35% of all waste oils in Europe were actually routed through this recovery method, through 24% treated as fuel or for fuel and 11% for energy recovery. So you can see it's still an important part of the overall piece. Next slide, please. And what we would say in terms of considering the overall end of life is, although it's better than disposal, then really where possible, then using it as a secondary fuel should be avoided where practical, in favour of practices higher up the waste hierarchy. And it should be considered as representing carbon leakage from the lubricants value chain. And with that, I'll hand over to Glyceria, who will start to talk about the next stage of that waste hierarchy.
You're on mute, Glyceria.
Thank you, Paul. So having covered the recovery section, we now move one step up in the waste hierarchy to recycling, and more specifically to regeneration, where used oils find a new life as a valuable resource. Waste oils represent the largest amount of liquid hazardous waste globally, and their management should be responsible in order to protect both environment and human health. The Waste Framework Directive sets the legal framework for this. 3 key articles are relevant and particularly important here. First of all, Article 3 that provides definitions, including waste oils and regeneration. Under the EU law, recycling and regeneration of waste oils means refining, the process of refining used oil to produce new base oils by removing contaminants, oxidation products, and additives. Second, Article 4, which introduces the waste hierarchy, prioritizing waste management practices. Prevention first, then preparation for reuse, recycling, recovery, and finally disposal. And third, Article 21, which focuses exclusively on waste oils. Article 21 requires member states to ensure separate collection of waste oils, prohibit mixing that would hinder regeneration, treat waste oils with priority to regeneration, and to support these, member states are also encouraged to use extended producer responsibility schemes and other technical and economic incentives. So the key message here is that regeneration is not just a good environmental practice, it is a legal priority in the EU. Now let's move from the legal framework to what happens in practice. Re-refining is fully embracing the principles of circular economy. Lubricating oil does not wear out. It simply becomes contaminated during use. In fact, 70 to 80% of used oils remain valuable base oil that can be regenerated indefinitely. The re-refining process is a closed-loop system. Lubricants are produced and enter to the market. They are used, and at the end of life, waste oil is generated. Waste oil is then collected from the various sources. It is transported to authorized refineries. Through processing, base oil is recovered as refined base oil, RRBO. RRBOs are then blended with additives to produce new lubricants, which then return again to the market. This cycle keeps hydrocarbons in circulation and supports resource efficiency. Let's take a closer look at how modern refining process works. Early techniques like acid clay treatment resulted in low quality, darker color and noticeable odor, and inconsistent product quality. Today, refineries apply advanced multi-stage refining processes similar to those used for virgin oil production. Key stages include, of course, quality control of incoming waste oil for the evaluation of suitability. This is an important step. Improper mixing should be avoided as it can significantly reduce the potential for effective regeneration. The process starts with pre-treatment to remove water, sludge, and solids using physical separation methods such as filtration and gravity settling. Then comes defueling and dewatering, where remaining water and lighter hydrocarbons are separated. Then vacuum distillation. At this stage, base oil fractions are separated from the high boiling asphalted residue and recovered under high vacuum conditions. Hydrotreatment and solvent extraction are techniques used to enhance the quality of the base oils. These steps improve quality, color, odor, and stability by removing sulfur, nitrogen, oxygen, aromatic, and other compounds. Fractionation is following where a base oil is separated into different viscosity grades. And final quality assurance, confirming compliance of producer RRBOs with specifications. Modern refining delivers high-quality base oils. Today, RRBOs achieve a Group 2 and 3 performance levels, offering high viscosity index, low sulfur content, and high saturates level. RRBOs are non-hazardous, compliant with REACH, meet the same requirements as virgin oils. And also refining processes generate lower emissions and produce minimal waste, resulting in significantly smaller environmental footprint. However, despite these advantages, only about 61% of collected waste oils is currently refined in the EU. The majority of the remainder is burnt as fuel or for energy recovery, wasting a valuable resource. So there's a significant room for improvement here. We talked about environmental benefits, and these are well supported by evidence. Recent LCA studies conducted by IFEU and the European Commission JRC show that re-refining outperforms across all key impact categories where compared with producing base oils from crude oil and treating waste oils to fuel for energy recovery. The numbers are quite impressive. When compared to primary base oil production, re-refining reduces resource depletion by up to 87%, saves 71% of CO2 emissions, and cuts fine particle emissions by 88%. By keeping hydrocarbons in use, refining prevents carbon leakage, supports decarbonization, and directly contributes to the goals of the European Green Deal. For lubricant manufacturers, using RRBOs provide measurable CO2 savings and strengthens ESG performance. Now, let's turn to what really matters for formulators and end users, quality and performance. Thanks to the improved feedstocks and the advanced refined technologies, RRBO are comparable in quality and performance to their virgin counterparts. Today, Group 1, 2, and 3 RRBOs are widely used in passenger car and heavy-duty engine oils, gear and transmission lubricants, industrial and hydraulic fluids. The industry is already aligned. Additive companies have developed specific programs with RRBOs, and also many OEM-approved formulations with RRBOs are already in the market with proven field performance. So quality is no longer a barrier. The remaining challenge is perception and awareness. And this is something lubricant industry can address through communication and demonstration of performance. Of course, re-refining cannot happen if waste oil is not properly collected. And here is where extended producer responsibility, or EPR, comes in. Under the EU Waste Framework Directive, producers and importers are responsible for ensuring proper management of their products at their end of life. While EPR is an individual responsibility for each producer, in most member states, this obligation is fulfilled collectively through dedicated EPR schemes. These schemes or organizations coordinate both the financial and operational aspects of waste management. Several well-established EPR schemes for waste oils are operational across Europe, serving as benchmarks for best practices, including schemes in Italy, France, Germany, Spain, and Greece. These systems share some key characteristics: close collaboration among stakeholders, producers, collectors, and refiners, strong national legislation, usually accompanied by clear collection and recycling targets, effective enforcement and rigorous oversight by authorities, and also public education and awareness raising on the environmental and health risks associated with improper waste oil handling. Where these conditions exist, collection and regeneration rates increase. Finally, here we see the current landscape of re-refining capacity and EPR schemes across Europe. According to the most recent data, re-refineries collectively process over 1.1 million tons of waste oil annually, producing more than 800,000 tons of RRBOs. This demonstrates industrial scale capacity, technological maturity, and clear potential for further growth, especially where policy, infrastructure, and industry align. So, we have now seen how regeneration helps maintain the useful life of oil and preserve its value. The next step in the waste hierarchy is preparing for use, keeping products functional before they become waste. And this will be presented by Mark. Thank you.
Thank you, Glycoria. So preparing for reuse is probably the least well-known slice of the waste hierarchy. If you could just move on one slide, please. Thank you. And so what does it mean? So essentially, it means reconditioning the lubricant or restoring that lubricant to a usable state without full re-refining. So it sits higher in the waste hierarchy than re-refining because it's less energy intensive, and in fact all of the lubricant is reconditioned, so you don't lose part of the lubricant, such as the additives, as you do with re-refining. It's not suitable for all lubricants, so lubricants used in applications where degradation and contamination are high, for example automotive or marine lubricants, aren't suitable for reconditioning. However, it is gaining traction as a suitable and cost-effective strategy in industrial maintenance. So it's suitable for lubricants like hydraulic lubricants, turbine oils, gear oils, compressor oils, and transformer oils. So let's take a look at the methods for reconditioning. So the methods really are dependent on the application, which means the severity and type of contamination and degradation present. So we have four main methods, and of course they could be combined. So we have physical methods, which would be filtration to remove solid particles and contaminants, centrifugation to separate impurities based on their density, dehydration to remove the water, and then there's magnetic electrostatic purification, which looks to target the metal particles, and then heating and settling to separate contaminants from the oil. So those are the physical methods. Moving on to the chemical methods. So chemical methods could include reagents to neutralize acids or restore additive balance, and then combined methods. So of course you can combine the physical and chemical methods. So these integrate those physical and chemical treatments. And an example there might be we have a filter that is functionalized with a chemical treatment. So it can take out some contaminants as it passes the filter. And an example there might be to remove acids to reduce the acid number of the lubricant. Then you have in situ systems such as the kidney loop filtration systems. Here you've got continual filtration while the machine's running, and that again is ideal for systems such as hydraulic and turbine systems. Then finally, you have additive replenishment. So that you could consider this as a chemical method, but it stands out because it refreshes the depleted additives without replacing the base oil. And of course, for that to happen, you're going to have to monitor the situation carefully. So monitoring of that oil within the system. So then finally, we'll look at the benefits of oil reconditioning. So again, the benefits will depend on the application and the approach that we use for reconditioning, but I'm listing the benefits that can be achieved. So firstly, there's the cost savings, so reducing the need for purchasing as much fresh lubricant, so less lubricant needs to be purchased over time. And it can also reduce the cost associated with production interruptions and maintenance downtime. So because you're optimizing the lubricant, then it's possible to reduce those interruptions. Sustainability, I already mentioned that it's less energy intensive than virgin base oil manufacture or re-refining. It conserves resources by using less lubricant over a defined time period, so reducing crude oil dependency. There are avoided emissions benefits as well. So if you can consider you use less lubricant over a defined time period, then of course the life cycle emissions related to those lubricants are lower for a reconditioned system. And finally, of course, it supports the circular economy principles by regenerating and reusing rather than taking fresh lubricant and also reducing waste there. And then onto the operational efficiencies and asset optimization. Again, this is all around optimizing the lubricant performance. So through reconditioning, you're optimizing the lubricant performance, and through that, we enhance the machine reliability and uptime by maintaining the lubricant performance. We can reduce production interruptions and maintenance downtime, and extend the service life of both the lubricant and then potentially the machinery as well. So the final point on here, which leads nicely into Andreas's part next, would be in combination with oil monitoring, you can develop a lubricants as a service model rather than the usual consumable model. And so with that, I'm going to hand over to Andreas to take us through the next step in our waste hierarchy journey.
So thank you, Mark. So the previous speakers have presented the various options of dealing with waste lubricants. In this section, we will talk about waste prevention. In the waste hierarchy, this is always depicted at the apex of the inverted pyramid. And as Gemma said in the beginning, it's the most desirable route towards sustainable development. If we can avoid the creation of waste at the source, this is what we have to do. Furthermore, waste prevention is one of the mandates of regulations such as ESPR, for example. In the 10R frameworks, there are three main points that we need to focus on: refuse, rethink, and reduce. In this section, we try to highlight these 3 points by providing some hands-on examples of how these can be applied throughout the lubricant supply chain. So we can do this by looking at 3 pillars. So looking at the first pillar, we need to minimize the amount of lubricant used and design components or equipment for optimizing service life and performance. We can achieve this by, for example, applying preventive or even better predictive maintenance strategies. Condition monitoring, as Mark mentioned, is one of the key tools applied for lubricants to achieve this. Another tool that is being applied in our field is minimum quantity lubrication, a method associated primarily with metalworking fluid application, but it comes from the more encompassing basis of the right lubricant at the right amount, at the right point. Looking now at the second column, we need to look at lubricants with extended service life. At the same time, we need to look at products that will extend the lubricated components life. if we look at the grease lubricated bearing, the impact of the grease in the bearing lubricant system, considering both sustainability pillars, the environmental and the economical, the lubricant impact is usually orders of magnitude below that of the bearing. If we can extend the service life of the bearing, our overall impact will be more significant. This is mainly where high-performance lubricants and synthetic products can play a role. In the third column, we need to consider the group of lubricants that end their service life, that when they end their service life, they don't end up as waste in the traditional sense. By means of application, these are some products that cannot be recovered as waste oils. There are applications such as chain oils or two-stroke oils, as well as lubricants that by design end up in the environment, like total loss lubricants or partial loss lubricants. So let's try to rethink how we monitor lubricants. I will not reinvent the wheel here. There are practices that have been used in our industry for a very long time, not just the lubricants industry, but throughout. These can be the low-hanging fruit in everyone's waste reduction strategy and can at the same time reduce both the waste and the operational cost. A lot of these strategies go hand in hand with the lubricant reconditioning that Mark discussed previously. There's a plethora of standards that can be used for condition monitoring. I've put the ISO standard on your screen, and it's a typical example of how a condition monitor for lubricants takes place. Typically, OEMs will require specific parameters to be monitored, and there are experts in our field that have built careers on providing advice based on monitoring specific physical and chemical parameters of an oil. If you're not familiar with this, I urge you to simply Google lubricant condition monitoring, and you will get more than enough material to go through. So where do we typically use condition monitoring? I've put some cases on your screen. This is definitely not exhaustive, but they are typical. So systems where operational parameters are constantly changing. Stationary gas engine, especially ones using, for example, landfill gas as a fuel. The acidity of the fuel will be changing constantly, so we need to monitor that. Large industrial systems where oil change is equal to long downtime that can affect operations. And lastly, critical systems like, for example, marine engines. If there's an engine failure, that risks the safety of the crew at sea. Or if we talk about steam or gas turbines in power generation, failure of these means the loss of power to infrastructure. So there are basically two takeaways from this. We need to reduce the waste components and spare parts through collect lubrication strategies, and we need to reduce the volume of waste oil. There are some typical examples of how we can do this. So let's now focus on the reduce and refuse pillars of prevention. We come to lubricants with extended life. Older passenger vehicles required an oil change every 10,000 kilometers. Nowadays, service intervals are as high as 30,000 kilometers. This obviously has to do with the metallurgy of the engine, the cleanliness of the fuel, but also the lubricant technology. Looking at the total cost of ownership, a product that lasts longer will generally have a lower cost of ownership. Additionally, fewer oil changes, for example, mean less volume of waste. In sustainability terms, it can be more important to look at the product handprint than look at the footprint. What is true in all cases is that the handprint cannot be ignored. Moving on to the second column and looking at the packaging, there are targets of using recycled content of plastic by 2030. These are already in place, and in some countries there are extended producer responsibility schemes, EPRs, like we discussed about the used oils, also for the packaging, where producers are financially responsible for the cleanup of these and the collection of these packages. Some additional points to consider. Make sure that components are well serviced and in good condition to avoid contamination that will reduce service life. A hydraulic system with a breather using silica gel desiccant will remain in optimal conditions for longer than an open system. This is clear. The other point, which is very important and we often ignore it, is monitor your inventory. large amount of lubricants pass their expiry date in storage prior to use. It is estimated that about 3 to 5% of all lubricants purchased will expire before they are used. Expired lubricant stocks must be disposed of according to specific regulations as waste oil, as improper disposal is harmful to the environment. Proper inventory management will ensure this waste is minimized. Again, we come back to the principle of the low-hanging fruit. So if we look at what we need to prioritize here, obviously we have the service life. We need to consider fill-for-life lubricants whenever possible, and we need to extend the lubricant life with technical means, such as the ones discussed previously by Mark. I want to say a few words about lubricants that don't end up as waste in the traditional sense, meaning they cannot be collected for re-refining. These are categories of synthetic lubricants that are not suitable feedstocks, such as esters and PAGs. In the first column, I've put a grease example. I mean, there are products that cannot easily be separated after the end of life, such as grease in bearings, for example, and the grease industry is looking into different innovative ways on how to collect grease. Some products evaporate or burn during their use, like two-stroke oils or chain oils, and thus cannot be collected. And lastly, we have lubricants that are designed to be released into the environment. These are the total loss lubricants or partial loss lubricants. Products in this last category are typically biodegradable, minimally toxic, and non-bioaccumulative. They are regulated under the EU Ecolabel's strict environmental criteria. And looking at these categories, we should highlight that clearly total loss lubricants do not conform with the circularity principles of sustainability, but they are a means to an end for applications where the lubricant ends up in the environment. Collector schemes are available for most waste oil, but some lubricants are not easy to collect. So we've looked at the prevention of waste generation, and there is one more thing I would like to discuss before I finish. And we often refer to lubricants as sustainability enablers in the sense that lubricants help reduce wear of components and reduce energy requirements through friction control, for example. And this is absolutely correct. In this sense, lubricants contribute towards clean technology. But I think we can add something to this. If we look at the technology evolution timeline, from the first documented use of lubricants in Egyptian chariots almost 5,000 years ago, to the Industrial Revolution, the first productive steam engine, to today's space age, lubricants are really evolution enablers. Try building the pyramids without any lubricants. I mean, it will take much, much longer, guaranteed. Or try running the rocket steam engine without lubricants. It will last for a few minutes before it seizes. Or try putting a rover on Mars without lubricant. This is impossible, and this is also part of the discussion about PFAS ongoing. And we're talking about the circular economy and how we need to look at circularity. There's one thing that is for sure not circular, and this is time. And with our lubricants, we need to look at how we can evolve these, how we can sustain technology, and how we can help sustainability move towards net zero. And we need to do this if we want to follow the Olympic motto of being faster, higher, and stronger. And with that, I will hand over to Gemma for your questions. Thank you.
Thanks so much, Andreas. Always ending just on a brilliant point. That's fantastic. Thank you, and thank you to all of the other speakers as well for your parts in the presentation. And thank you to the audience for engaging with it, for engaging with us, because I can see lots and lots of questions coming through. Glikaria, your part was incredibly popular. I've got some questions coming your way. So if I could ask you to come off mute, that would be great. But I'm going to bring Joris back into this discussion first and foremost, because you've had a bit of time off. So I'll start off with you, Joris, if that's all right. So given that disposal, so that the first bit that we covered of the waste hierarchy being the least preferred option, what are the barriers then preventing industries and companies from moving up the waste hierarchy? Why is lubricant still being disposed of? What are those barriers that you see?
Yeah. Thank you. It's a great question, actually. And I saw one of the questions also in the chat that one was asking, why aren't we increasing the amount of re-refined or products based on re-refined? And it links to this question. And there are some limitations. And I'd like to start with maybe the technical limitations that we are. So some products do contain contaminants, acids, and other types of fluids that if you'd like to re-refine them and not dispose of them, it's difficult. So there are some technical limitations, and we need some innovation to solve that. Also, for example, the take-back programs for esters, for example. Esters are difficult to re-refine at the moment. There is a project in Italy that is looking at this, which is the LIFE project, but innovation is really key. Then the second thing is, of course, the money. Yeah? The economic factor is always important. It is there's a lot of investments involved in setting up re-refining facilities. So that's another factor that's hindering the let's say the moving away from disposing. Then the awareness, I would say, as well, the knowledge gap, basically why we have this webinar today, to also inform and share knowledge to close that knowledge gap that is out there. And I would say the last point I'd like to mention is the infrastructure and logistics. Also one element why we're not moving up that hierarchy is that there are, of course, re-refiners in some countries, but not in all countries. It's not so easy to ship waste oils from one country to the other. There's also taxation involved as well. So having that logistics and infrastructure in place, and we as an industry have a responsibility there to set that up correctly. But if we do, that would open up more opportunities from moving away from the disposal part. So plenty of opportunities there. So those are the things that I would say are very important, Gemma.
Thanks, Joris. I was just super excited to hear your answer that I forgot to put up the Q&A screen. So what I've done is I've just I've popped up the QR code to the document again for you to scan, download and read. Should also mention that we do have a lot of questions coming in and just over 10 minutes to get through them all. But if you do think of anything after the webinar, then please do get in touch with the Secretariat. The email is there on the screen. We will be compiling all of the questions at the end and putting together responses for them. So don't worry if we don't get to your question. We will after this session. So the next question I've got is, Joris, I might come to you first, and then Glikere, you might have some thoughts. And this is around PFO. The question was, is PFO a legal practice adopted in the UK? As far as I'm aware, is that processed fuel oil? Joris, did you have any thoughts on that, or any UK folks want to jump in as well? Please go ahead.
Yeah, I can start. Maybe Paul is from the UK, so maybe Paul can start. But maybe from my side, I can say it is something that is used. So the processed fuel oil, it's something that we would like to move away from, because it's using lubricant as a fuel, yeah, I would say it's you need to treat the oil as a product and not so much as hazardous waste. So there may be some let's say rules and limitations there in terms of permits, but it's still a common practice at this moment. And maybe Paul, I'm not sure if you can add to this.
Just a little. I mean, I think you're absolutely right. It's not illegal, certainly in the UK, but it's not considered best practice, and I think that's, things are moving away from that. If you've got waste streams, then they've got to meet specific standards, and I think it's there's a British standard for that, which would look at ash content, total halogens, PCBs, things like that. So it's quite regulated. And also I would add as well, if the waste isn't treated or isn't handled properly, then it doesn't come under the recovery criteria as such. You'd almost consider it disposal. So again, really, we should be looking further up that waste hierarchy and not dwelling on these sort of older practices.
Brilliant. Vickery, I'm not sure whether you had anything further to add on those points.
Yes. In the case of PFO, producers and users both need environmental permits, and as the oil has to meet certain specifications in heavy metals, halogen, sulfur concentration to ensure that emissions limits are met. And also, as Paul and Joel said before, as the policy is moving away from recovery and treatment to fuel oil, this practice is a decline.
Okay, thank you, and thank you for the question. It was a good one. I learned a lot. Andreas and potentially Mark as well, I might come to you on this. So you mentioned some examples of condition monitoring, reconditioning, the kidney loop filtration. You mentioned a lot of techniques, and Andreas, you summarized the condition monitoring and as well. These all seem like quite big things. So how can smaller SMEs and smaller companies potentially assess whether their used lubricants are suitable for one of these? Like when a lubricant is at the end of its life, how do we assess what to do with it? Like what's the right avenue to take there?
Well, you cannot start when the lubricant is at its end of its life. You have to start earlier. So the practice is that you have to monitor the condition of your oil since the point you put it in your system. And this is not new. This has been a practice, especially for critical applications, for a long time. But what we see on the market is still a lot of end users are not using this tool to take advantage of the benefits, both in terms of sustainability and also in terms of operability of their business. So condition monitoring is not just limited to the oil. I mean, there's a large amount of test houses and laboratories that will provide this information for you for a relatively low cost, comparing the investment both in the lubricant and your equipment. So it simply makes sense to test your oil at different stages based on the hours, or based on the mileage, or based on the conditions of your operations. But a lot of companies still don't do it. And we are the lubricants industry, so we talk about the oil, but there are also other ways to look at condition monitoring. There are acoustic ways. You can look at vibration. You can look at noise. There are a lot of different things that can happen today, and the actual implementation, due to the rapid adaptation of technology, are fairly low cost, and they can, at the end of the day, they can save the user of the lubricants, the operator of the machinery, a substantial amount of money, if we use the reconditioning techniques that Mark discussed.
Yeah, it's a great point, Mark. I'm not sure whether you had any builds on that at all.
Only really that there are newer and newer techniques coming in now, and some include AI, of course, is the big buzzword of the time. But I wanted to go back to the very beginning, because actually when we first started looking at lubricant monitoring, it was more about total cost of ownership. It was to reduce cost, both for the machinery and in the lubricant. But actually, the sustainability side is also high. So we've been doing it for a long time, but we didn't talk about sustainability in the past. But actually, it's a very sustainable practice as well.
Brilliant, thank you. I'm just conscious of time and the fact we have 4 minutes remaining. So what I'm going to do now is just ask a general question. I'm going to pit all of the presenters against each other, and I'm going to ask you, as an industry, in your opinion, what part of the hierarchy should we focus on as an industry to have the best environmental impact? I know, for example, Glyceria, you put forward a great case for the use of re-refined base oils and re-refining, and so many great ideas. But if you had to put your money and efforts into one level of the waste hierarchy, where would that be? I don't know if anyone wants to go first.
First of all is prevention. If it is and the preparation for reuse, but if the oil reach the end of life, then the best practice is regeneration. This is considered the best environmental option because it keeps used oil in the circulation by recovering base oil back, which is further used for lubricant production. So LCA studies show that regeneration results in significantly lower CO2 emissions, reduced air pollution, and less resource depletion compared to both virgin oil production and treatment of fuel for energy recovery. So regeneration is the best environmental option after prevention and preparing for reuse, as it maintains material value, prevents waste, and it delivers the lowest overall environmental impact.
I like it. Any contenders?
I'm going to give the, I guess, the diplomatic answer. So it depends. It depends on many things, and we should always aim for the highest level of the waste hierarchy. But it will depend on the type of lubricant. Can it be re-refined? It will depend on the level of degradation and contamination. And so wherever you are in the waste hierarchy, you should aim for the best possible outcome for that level of contamination, that type of lubricant, that application, that level of degradation. And we should keep pushing for those that are in the lower categories, such as disposal, about ways in which we can push those lubricants up the waste hierarchy.
Thank you, Mark. Joris? Andrea?
Yeah, I would say that there are two elements to this. The first thing is we want to become circular. I would say recycling is critical there. So that's where we can have a high impact. But secondly, also just reducing the amount of waste. And that is more in the prevention part. So I would go with the prevention part, because there's so much things that we can do still as an industry, and there's so many things where we can improve our impact there by the things that also Andreas spoke about, like oil condition monitoring, looking at storage and how we deal with that. So both two things, reducing, so prevention, but also recycling, where we can have a major impact. And yeah, maybe some other thoughts as well from the rest.
Andreas, I'll give you a final minute. I'm conscious of time, so I'll let you have the final word.
I won't take more than 1 minute. I mean, we're all on a sustainability journey here, and we've done a lot of steps. We're learning to walk, obviously, before we run. And over the last few years, RRBO has gained a lot of popularity because it seems that you're getting a lot of sustainability benefit by very quickly, as a lubricant formulator at least, you're getting a quick solution, a quick benefit from the use of RRBO. But this is, in my understanding, still just a step in the right direction. And if you ask me then what the best line of action is, for me it would be in the waste hierarchy pyramid, one step above prevention. And what that is, I'm challenging everyone on this panel to think about it. I mean, prevention is not the end. The sustainability doesn't end anywhere. We have to strive always to improve.
I like it, and I think that's just an absolutely solid, great message to end on. We're a minute over. We've had so many great questions coming in. So what we'll do is we'll compile those. We'll put together a nice Q&A response document, and we'll make that available for you. So please don't worry about that. So yes, last chance to scan the QR code to access the document, and just remains to be said to have a great rest of the day, evening, afternoon, and thank you again for listening. Thanks, everyone.
Thank you all. Bye-bye.
Thank you.
Thanks.
Thank you. Bye-bye.
Bye.
Thank you.